Hey, so today we're starting a new chapter, which is Organic Chemistry, chapter 10, not chapter 6. So for organic chemistry, this is my special field. So organic chemistry, in my opinion, it's the most fun. So we're going to start with what is actually organic chemistry. So you have probably heard the word organic before. Maybe you've heard about organic food, but that's a bit different than organic chemistry. So organic chemistry is also called the carbon chemistry. And the carbon chemistry, so almost every compound that contains carbon are organic chemistry. But just almost. So we have some exceptions. And the exceptions are, for example, carbon dioxide or carbon monoxide, and also everything that's pure carbon. So, for example, pure carbon. So, for example, diamond or graphite. And for the most of the time, we have carbons and hydrogens connected together in organic chemistry. So we have carbons and hydrogens. The carbon and hydrogens, if it consists of only carbon and hydrogens, we call them hydrocarbons. So the hydrocarbons are only carbon and hydrogen, and we're going to look at one specific hydrocarbon. And that specific hydrocarbon that we're going to look at today is called alkenes. So we have these alkenes. It's only carbon and hydrogens together, singly bonded. And what we also call, so when you have a certain type of organic compound like alkenes, only carbons and hydrogens, singly bonded, they make a homologous series. And a homologous series have a same general formula, but they differ from each other by one unit. So we can have a look at one alkene, the most simple alkene of them all. It have one carbon and 4 hydrogens. And this one, maybe you know it, but this one is called methane. It's called methane. So this is the start of one homologous series. And the formula of this homologous series, which is called alkanes, the formula is CnH2n plus 2. So we can check for methane. So for methane, N is equal to 1. So we have C1. Now I'm using this formula. H, and we have 2 times N, which is now 1, plus 2. And normally we doesn't write the number 1. If we just write a C, it corresponds to 1. So we have a C, we have H, and then we have 2 times 1, which is 2, plus 2, which is 4. And then I can skip the brackets, and we can just write 4. So C, and we have 4 carbons, so We have carbons and 4 hydrogens. 1 carbon, 4 hydrogens. Okay, we see that this formula is okay for the first one. And the thing is that the members of the homologous series have the same chemical properties, but they differ with physical properties as an increase. So what we can do is that I can show you some more in this homologous series. So the next one is ethane. So if you write ethane, we know that N increases to 2. So then we have C2H, and we take 2 times 2, which is 4, plus 2, which is 6. Okay, so when we try to draw this, we need to connect the carbons, and then we add hydrogens. And what you probably already know from the Lewis structure is that carbon wants to have 4 bonds. Hydrogen wants to have 1 bond. So this is the only way that all of the carbons and all of the hydrogens will be happy. Okay, so we try the next one as well. That's propane. Oh. Okay, let's check. So we try again. So propane. We will look at the names soon. So for propane, that's N equals to 3. It's the next one in the homologous series. So then we have a carbon 3, we have H, and then we take 2 times 3, which is 6, plus 2, that's 8. And then we add all of the carbons together, add the hydrogens, okay. So what we actually see from this point is that we add 1 carbon each time, and we add 2 hydrogens each time. So actually the unit for alkanes, as I said, that a homologous series have the same general formula, but it differ with 1 unit. So the unit is CH2. That's what we increase with every time we move up the homologous series. And I also mentioned that it have the same chemical properties, but they differ in physical properties. So if we have a look at, for example, the boiling point, boiling point. So I'm going to write the boiling point here in green. So the boiling point is a physical property, the same as a melting point. Chemical properties are how they react, how many electrons and that stuff. So the boiling point for methane, is a negative 161 degrees Celsius. So that's quite cold. For ethane it's a little bit higher, but still quite cold. It's 89 degrees Celsius, and for propane it's 42 degrees Celsius. So what we see is that, okay, all of these have a pretty low boiling point, but we see that it increases. So we started at a negative 161, and it becomes a little bit warmer and then a little bit warmer again. So if we move further up this homologous series, we will have an even higher boiling point. And that is common for all homologous series. So the melting point and the boiling points are increasing when the number n increase. So we're going to look at the 10 first. 10 first in the homologous series of alkanes. So we're still talking about alkanes. But now we want to look at the names. So N, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So for the first one, we already know the name of this one. It's methane, right? Then you have ethane and propane. And then we have butane and pentane, hexane, heptane, octane, nonane, and decane. And what do we see for all of this one? What is common for all of this one? It's that it ends with ane. You see that? Methane, propane, butane, pentane, hexane, heptane, nonane, octane, nonane, and decane. So actually that's kind of the surname for all of these compounds. So imagine that all of these compounds, all of the alkanes, they are brothers and sisters, and their surname is ane. So whenever you see a compound that stops with ane, you know it's alkane. And what's in front says something about how many carbons you have. And this is the way we count in organic chemistry. We count met, et, prop, but, pent, hex, hept, oct, non, dec. And you need to know the counting of the 10 first. So you need to know how to count in the organic chemistry way up to 10. Because this we can use for many other homologous series as well. When it stops with ane, it's an alkane.